So last time we were looking at this data from the haircut prices, and we've got clearly the women on average are paying more than the men, at least in our sample. But the one thing we've learned over and over again in statistics is this is just a sample, and samples vary. So even with the variation in samples, would we be comfortable saying that in the entire population, women on average pay more for haircuts? So what we want to do is simulate the idea and see what the likelihood is to have gotten something like this if there really was no difference. So we're going to do similar to what we did for, if you remember with the card shuffling, we're going to do essentially that here, but with the two populations. So we're going to take this data and I'm going to go to the multiple means because we really want to compare the means of those two populations. So I'll clear out the data that comes in there and paste in our haircut data, and there it is as just a histogram, and I'm going to lay the box plots on there again, so we got our box plots. And so we want to simulate the situation where there really is no difference. So the idea is we take our price data. So if we look at, scroll back up, we'll take these price values, all of them, and just randomly deal them out to the men and women. So if there really was no difference between what men pay and women pay, that's what you would expect, random assignment of prices to their haircuts. Then over the long haul, we should expect to see no difference. So that's simulating a situation where the gender doesn't really matter because we are just randomly dealing out prices to them. So let's turn on the shuffle options here. And so notice the hypothesized difference. There's our mu2 minus mu1. We're hypothesizing the null is that there is no difference. And we want to show that there is evidence that there is a difference. So let's do just one shuffle. And so all it's done here is take those women and men values and shuffle in the price values. And then it's calculated the difference in their means. So the average price of haircuts for men minus the average price for women, and got this negative 1.68 and plotted it here. And so we want to build up a null distribution of what you would expect to see if there really was no difference. So we could keep shuffling them. Each time we're getting some difference between the two. And then each time it's calculating the difference in means there. Sometimes more than 0, sometimes less. Now let's crank it up to maybe 100 shuffles at a time. And now maybe 1,000 at a time. And notice we're starting to get somewhat symmetric bell-shaped curve. Remember, we saw this before when we were doing differences in proportions. Right? The key feature here is that this mean is centering on 0 roughly. Right? In the long haul, we should expect that mean to approach 0. What does that say? That says that if you were just randomly assigning prices to men and women, in the long haul, the average difference would be 0. Because there shouldn't be, men should not be paying more or less than women on average if all we're doing is randomly assigning prices. And so that's what we're seeing. So now the question becomes, if this was the case, if there really wasn't any difference in the prices of men and women's haircuts in the population, would we expect to see, where's our original one? We observed a difference in means of 32.208. So what's the likelihood of that happening? So very unlikely, right? I mean, it does happen randomly, a little bit. It happened 45 times out of the 22,819 simulations. But it would be very unlikely if you were just randomly assigning prices, which is equivalent to there being really no difference in men and women prices, to have gotten in our sample a difference in the means of 32.208. So this p-value, as we know now, a p-value of 0.002 is very, very small. We would be very, very comfortable rejecting our null hypothesis here that there is no difference, and we would be comfortable saying, yes, women are on average paying more for their haircuts than men are.